Okay, take a look at question 3. Same thing, we have a quadratic function given. So let us define our quadratic function. You are told that this function is divisible by x minus 2. This means to say that your factor must be equal to x minus 2. So in this case, the value of x that you will use will be 2 for the remainder to be equal to 0. So f bracket 2 would be equal to 0. So in this case, please replace all your values of x by 2. And if I were to simplify it, this is what I will obtain. Further simplification will allow us to get. Now, same thing, please do your factorization. You will notice A will be equal to 3 or A will be equal to 4. Please do not accept both answers readily because take a look at part 2 of the question. You are told that it is divisible by x minus 2 but not by x minus 1. Let us replace our value of a of 3 and 4 into the original polynomial function. So, when a is equal to 3, fx, when you replace a by 3, will be equal to negative 5 x squared plus 15x minus 10. Okay, now let us try out. If I were to make x minus 1 my divisor, so I will put the value of x to be 1 inside my function. Notice my remainder will be equal to 0. This means that x minus 1 is a factor. So, it contradicts what is given in the question where it is not divisible by x minus 1. So, in this case, we will reject a is equal to 3. Now let us take a look at when a is equal to 4 in this case. Same thing, replace your a by 4 and find out what is your new polynomial function. So if you were to substitute x is equal to 1 inside, the remainder is equal to 1. This means that x minus 1 is not a factor. And this is consistent with the information in the question. So we can conclude our value of a would be equal to 4. Clearly, you can see the use of the remainder and factor theorem in your question 3.